Imagine waking up tomorrow morning to a world that's just gone dark. Your cell signal, completely dead. The TV is just static. Out in the oceans, massive cargo ships are drifting aimlessly, and up in the sky, airplanes are suddenly grounded because they can't trust their navigation systems anymore. Emergency lines are struggling, and financial markets are totally freezing up. But here is the absolute most terrifying part. There was no giant explosion. There was no enemy missile strike. We're looking at a sudden cascade of earthly failures. No GPS, unstable internet, grounded flights. But the cause isn't happening on the ground at all. It's happening hundreds of miles right above our heads. You see, this global blackout is happening because our own space debris, all that junk we've left behind after decades of launches, has finally hit a breaking point. It's silently tearing apart the very infrastructure we rely on every single day.
Section 1. The invisible storm begins. Okay, let's dive into this. To really understand how we get to that terrifying blackout, we have to look at what we've been leaving up there. For decades now, we've been launching rockets, satellites, scientific missions, but we haven't exactly been cleaning up. Think about the sensory contrast here. When we look up from Earth, we see this peaceful, calm, unchanging sky, right? But the reality of low Earth orbit? It's a violent, highly crowded graveyard. It's packed with discarded rocket bodies and dead satellites moving at absolutely unimaginable speeds. There is literally an invisible war of physics happening just above our atmosphere, completely hidden from view.
And the scale of this threat, it's terrifying. Just a marble. That's it. You don't need a huge school bus-sized dead satellite to cause a total catastrophe. Because these objects are moving at orbital velocity. We're talking thousands of miles per hour. A piece of junk the exact size of a marble basically carries the kinetic force of a bomb. Moving that fast, it can completely shatter a multi-million-dollar active satellite in a fraction of a second.
Section 2. Earth's fragile nervous system.
Now, what's really interesting about this slide is how interconnected everything is. We often just think of satellites as tools for deep space exploration or maybe getting our evening weather forecast, but they actually act as the invisible nervous system for the entire planet. Banking relies heavily on them for global timing signals to process transactions. Farming depends on them for precise weather and rainfall patterns. Emergency logistics teams absolutely need satellite comms to coordinate in disaster zones, and our energy grids use them for system synchronization. So a loss of satellites doesn't just mean you lose a TV channel, it instantly cascades into massive human crises across all of these foundational sectors.
Section 3. The collision cascade.
So, how does the nightmare actually start? Well, it doesn't happen everywhere all at once. Usually it starts as just a single spark in a highly crowded altitude, just one unlucky collision between a dead drifting satellite and an old fragment of metal. And that triggers what's known as runaway debris syndrome or Kessler Syndrome. It's a self-sustaining feedback loop. Every single orbital collision creates thousands of new fragments. Those new fragments instantly become new bullets, increasing the odds of future collisions, multiplying exponentially until space becomes entirely unusable. And remember, ground teams cannot negotiate with physics. You can't just ask these fragments to slow down. Just trace the steps of this chain reaction. Step 1, debris hits a satellite. Step 2, thousands of new fragments violently scatter. Step 3, surrounding satellites are forced to burn their precious fuel just evading these incoming hits, stressing the system. Step 4, the orbit becomes completely unusable. It's a massive snowball effect. One crash breeds 10. 10 breed 100. A highly localized hit rapidly becomes an unstoppable wave of destruction, threatening the entire orbital lane.
Section 4. A civilization unravels.
Now, it's crucial to understand that our civilization wouldn't just collapse in one dramatic movie scene. It's more like unraveling in layers, as we slowly lose confidence in systems we completely took for granted. Within hours, your GPS apps freeze up and online banking starts lagging. In days, severe weather hits communities without any warning because our forecasting models are suddenly blind. Over weeks, military commands start seeing alarming gaps in global surveillance. And within months, a complete systemic loss of trust in digital systems. These technical glitches quickly evolve into a huge psychological shock, leaving humanity feeling entirely helpless against a threat we can't even see.
Section 5. The global blackout.
Eventually, we hit this orbital blackout phase. This is where the debris field in certain orbits grows so incredibly dense that launching new rockets becomes fundamentally too dangerous. Space agencies are forced to delay launches, insurance premiums skyrocket to impossible heights. Basically, the orbital highway closes. And the real-world collateral damage? Massive. Rural and ocean internet completely fails.
Natural disaster response slows to an absolute crawl. Aviation routes face heavy delays. But here's the really tragic irony of it all. Earth observation becomes patchy, and climate change monitoring is halted. Our very efforts to fight climate change and monitor natural disasters down here on Earth would be severely crippled by the huge mess we made up in space.
Listen to this thought for a second. Every broken satellite would represent not just a piece of hardware lost in space, but billions of dollars in infrastructure, data, and service continuity damage on Earth. That is absolutely crucial to grasp. This isn't just a niche technological hiccup for astronomers to worry about. The destruction of our satellites is a civilization-scale issue. It touches the economy, our safety, and our daily routines, all at the exact same time.
Section 6. Preventing the downfall. Because space debris obviously doesn't respect national borders, an international response would be immediately forced upon us. A piece of junk launched by one nation can easily destroy the multi-billion-dollar satellite of another. So despite all the usual politics, competition, and mistrust, global coordination becomes an absolute necessity. Which leaves us with a really critical question. Do we wait for a catastrophe, or do we act now? Seriously, are we going to wait until this dystopian disaster scenario plays out and our screens actually go dark, or will we take immediate responsibility and stewardship of our orbital environment before it's literally too late?
So the crucial point is that we actually already have the ideas to fix this. Engineers are actively designing robotic capture systems to grab old junk. We have concepts for drag sails that can be attached to dead satellites to safely pull them out of orbit. There are even laser concepts that can gently nudge debris right out of a collision path. But we also urgently need strict international end-of-life disposal laws and new heavily shielded satellite constellations. These are the proactive steps needed right this second to avoid that runaway debris syndrome.
Prevention is always cheaper than rescue. A million small, responsible choices are vastly better than one giant emergency. You know, humanity is fantastic at expanding, building, innovating. But historically, we are terrible at cleaning up after ourselves. We just kind of assume the environment will absorb our waste. But in space, there's no rain to wash away our mistakes. There's no wind to clear the dust. Our mistakes up there stay up there for a very, very long time.
Our progress shouldn't become our downfall. Will we treat space as a shared, fragile environment, or just a limitless dumping ground? Every great human achievement carries immense risks, and we absolutely must advance wisely. We really need to start cleaning up our act today, before the silence above us becomes impossible to ignore. Thanks for joining me on this explainer, and remember to keep looking up.